is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey, where am I? Hey, what are you doing here?
Hey, what are you doing here?
Hello, everybody. It is I, Mark Antonio, as you can see right there, and it is her, Tara, as you can see right there. And we are here to bring you another live show of Sky Tour Radio. And we call it Sky Tour Radio, but it's not really radio anymore, is it?
No,
I mean, what do we call ourselves now? Is it the Sky Tour Multimedia Extravaganza?
Yes, I love it. Love it.
Ooh,
Yes.
It can't be Sky Tour live stream, right? Because we do that with the telescopes.
No, with an extravaganza, we get fireworks and all sorts of fun stuff. So,
yeah, I gotta find fireworks. We gotta find some fireworks.
Okay.
Anyway, so how are you?
Good, good. How are you doing?
I'm doing fine, thank you. Fine.
Glad to be here. I can't wait to see what you have to show for it.
Oh, I bet you know a little bit about what I'm doing.
I know a little bit, but
yeah, well, she knows a lot of it, folks. Not a little bit. She knows a lot of it. Okay. So which reminds me, did you ever have Welsh rarebit?
No, maybe I have. Are they little pieces?
No, it's a cheese sauce that you make with beer.
I'm sure I haven't had it, but boy,
and you put it on crackers, and it's my mother
okay.
used to make it on toast. Yeah, it was really good.
So are you going to make some for all of us, Chad, everybody?
I know the whole. I got to make some for the whole class.
Yes, now that you've mentioned it, we're all going to be like thinking of cheese now.
Yeah, I'm gonna tell you something honestly and truly, and that is that when I was younger and in grammar school, I was chewing gum in the class. And the teacher had said something to one of the classmates weeks earlier, and I was ready for her. She saw me chewing gum, and she goes, "Mr. D'Antonio, are you chewing gum?" And I went, yes, Miss Rush. And she goes, "Do you have enough for the whole class?" "Oh, yes, I do." And I got up and I started passing out Dentine to everybody. My mother worked in a dental office, so she got all this Dentine. I was passing it out. And she goes, "Sit down." Well, I just found I had enough for the whole class.
Oh, it's always one in every class. Oh my God.
I started laughing. I finished passing it out to the 25 kids in the class. I sat back down, and then the teacher, Miss Rush, bless her heart, I was a nemesis. It was 6th grade, actually. And she goes, Nobody take any of that gum. Mr. D'Antonio, throw that gum away." "Okay, Miss Rush." And I threw it away. "Wrap it in paper." Yeah, I wrapped it in paper. And so I threw it away. But I had enough for the whole class, and I gave it out.
Wow, that was very generous at such a young age. You know,
I had a big bag of it because my mother would bring it home from the dental office where she worked as a receptionist and assistant to the orthodontist.
Nice lady. That's awesome.
Yeah.
Great.
Dentine. Yeah, you see, Dentine used to be the thing, remember?
It was so small. It was just really cool.
Yes, and then Trident. Remember Trident was another one? Okay.
And then after you chewed them for a few minutes, they just tasted like rubber.
It tastes like rubber. It tastes like a petroleum distillate in your mouth. Like, you know.
But those first few chews are great. You know?
Yeah. And if you had braces, forget it.
It's been a while since I've chewed gum. But you probably were chewing it then, huh?
Yeah, it was.
That's funny.
Yeah, they let me. Well, they didn't know, but they said, "Yes, Marky, you can chew them after you get your braces off. You can chew all the gum you want." Really? All at once? Well, no, not all at once. Anyway,
every dream, just shove it all in your mouth.
Right? Oh, then like this. "How you doing?" "I'm okay."
And then try to blow a bubble through this thick wad of gum.
Like Curly and the Three Stooges.
Yeah.
Trying to do that. Oh, yeah.
Oh, silly.
Who, me? No.
Yes.
Well,
Oh,
silly.
that's
Well,
funny.
I guess I'm silly. And tonight's radio shows a little bit of the silliness,
Yes, it is. Oh.
Yes. Tim F says the rainbow stripe gum had 7 seconds of flavor. Yeah, literally. That's right. That's right. It's absolutely right. Yep.
It was good 7 seconds.
Yeah, 7 seconds and it was gone. They go, yeah. That's why school chairs had it underneath them all the time.
Yeah.
So, but silly, being silly is kind of what today's theme is, isn't it?
Okay. Well, we'll all fit right in.
Well,
I'm speaking for myself. Sorry.
I'm going to give you a run for your money on that.
Okay.
Okay, because I'm going to be silly too. Because one of the things we're going to talk about is some of the more fun and interesting and silly cases that I've had to do in the UFO arena for television shows. Now, I've done a lot of television, as most people know, and so what we're going to talk about is some of the silliness and some of the really cool fun in cases that I've done. So it's entitled "What on Earth Is That?" Some of these cases came from the TV show "What on Earth." Some of these came from the TV show NASA's Unexplained Files. Okay, and so my current gig, if you will, is History Channel's The Proof Is Out There.
Cool.
So I did
Seen it.
You have, right?
You're on there all the time. It's awesome.
I know. I keep buying you new TVs because every time I come on, they go,
they blow it up.
So yeah, so for What on Earth, I was on Science Channel. That had to be, and it was NASA's Unexplained Files first. Okay, they're out of order there, so I can't change them. But I was on there for about 3 years. What on Earth for 2 or so. Proof Is Out There the last 5. Okay, so we're almost a decade in on these shows. And what I would do is I would be their video and image analyst, so I'd analyze video and imagery. So it's kind of cool. But the first case that I dug through the archives and I put together this presentation to kind of show you some of the fun stuff. Okay, this is cool. Now, we're familiar with Google Earth and how Google Earth makes some really silly looking images sometimes, right? And not everyone knows what's going on with Google Earth. Now, I, Mr. Big Shot, okay, I had to figure it out, didn't I? And in
Who do
figuring
you
it
think
out,
you are?
who do I think I am?
Mr. Big Shot?
Definitely not who I think I am. But the bottom line is that Google Earth is oftentimes representing the images that we see in a way that's in part due to how the images are put together. And sometimes the exposures are off a little. Sometimes they're sort of double exposures. We're going to get into all that. But then there's some downright silliness that I get as cases. And everything in this talk that I'm going to show you are cases I've actually had.
Oh, okay. Funny. Okay.
Yeah.
Cool.
This one is a good one. Okay. I got this. This is a cruise missile that was captured on Google Earth. Okay. Now, up here, you can see a ghost image of it. That's not the real thing, but that's just, that's actually a ghost image of this that was captured along with this actual image here. Sometimes you catch ghost images and that's what you see there. But the actual object is here. And you'll notice it's a long object with 2 little stubby protrusions here, right?
Yep.
Okay. Now, this was heading straight towards Salt Lake City. And the question is, was it a military drone or something that had gone rogue? Was it another attack by a foreign country? And those are the questions.
Did the sirens go off?
Yes. Well, matter of fact, they did not. And the thing, and I checked that because I wanted to know where else would we've heard about this. Well, was it maybe on a test range and it only went a short distance? Okay, that's the other question, right? Well, the answer is that this is what a cruise missile looks like. You can see the stubby wings there. Okay, and it has that shape. It's definitely white. It has the stubby wings. Okay, pretty cool. So I thought, well, they thought, okay, this looks like a Tomahawk cruise missile. prove us wrong. So I set to looking at the imagery again, and I began to notice something very important. The
Yep.
contrail of this missile has got a 2-trail path behind it. So it's 2 contrails that merge back into one as it starts to dissipate and get, in the
Right.
turbulence of the wake. So cruise missiles only have 1 engine exhaust, and there it is right there. Only 1 engine. They don't have 2. So that started to unravel it. And then I did a little further processing. And to be fair, I will be fair. This one took me all of 12 seconds to figure out. Okay.
Of
But
course.
I'm dragging it out a little bit because I have to go through the steps, right? Because the way I do analysis is I analyze,
Right.
analyze, and all along the way, okay, I could throw it out as a known, okay,
Right.
all along the way. And by the time it gets to that narrow bottom, whatever pops out of the bottom, however unbelievable, must be the truth. So I'm always looking for those cases that come out of the bottom of the analysis funnel. So this one fell out of the analysis funnel almost before it went in. Okay. Right at the very top, it fell out. Okay. The double contrail, big clue. All right. And then I noticed that wasn't the only problem. And that was the object had more detail to reveal. And when I did some processing on the object, it turned out that this is what it looks like processed. Notice we have some other details in this image now. We have these dark spots up front. Okay. And we have some other objects here. I see these wings. Do you see those wings?
I do. They're so faint, but yes, they're
There they
barely
are. There's
there.
one there and there's one there. So what is this?
And so,
Well, go ahead.
well, is that a plane, and are those the cockpit, the eyes up there at the top?
Yes. These are the cockpit windows. Okay. Now, this is a regional jet, and it has a high T-tail on the back. All right. And you'll notice at the back, it has this bulbous stuff sticking off the back here. Those are the 2 engines on the side at the back. You've seen these regional jets. Now you might say, but wait, what's this white thing? These white things here and here. Well, on this particular aircraft, this particular type of regional aircraft, the inboard section just outside the passenger windows is painted white.
Oh.
Okay. Yeah, that's
Just so
white.
happens.
Yeah, and the wings are silver, and so they tend to blend in with a moderately darker or neutral background, and that's what we're seeing here. And if you're careful, you can actually see the T-tail right here. See that?
It's just kind of a shadow, sort of.
It's a blur.
Yes.
Yep, the T-tail right there. So this turned out to be this turned out to be really, really, really simple to do.
Yeah.
But it was pretty crazy. And of course, other people are making good observations. Okay. Like Donald talks about the contrail being the same color as the road.
Right.
Okay. And yeah, it's true.
That was great. How cool.
Yeah, neat stuff. So this particular one then, as it turns out, wasn't, a UFO. But it was an interesting one.
It is. I have a question for you, if I can, on that ghost shadow. Is that the same as like a lens flare when the photograph was taken, or?
Yeah, this when the photo was taken, here's what happens. The photograph itself, when it was taken, this is the brightest object in the view. Okay, so if you notice this color here kind of looks bluish. Okay.
Yep.
That's because there's coatings on the lenses that are taking the pictures, and the lens coatings tend to show a blue coloration. Okay. And this dark thing here is sort of like another tertiary reflected internal lens reflection, because it's multiple stacked elements. So we're getting multiple sets. Okay, in here. It's the brightest thing in the field, so that's where you're going to see it. This is soft and gushy out here, so you don't really see a whole lot there. This is sharp and exact, so it tends to show up better.
Cool.
Yeah, it's pretty interesting.
Cool.
Yep. So as you can see, this was the final determination.
Oh,
regional T-tail jet twin, like like a CRJ 700 or something like that, or
Nice
so.
little cushy ride, I'm sure.
Yeah,
Mhm.
usually 2 and 2,
Mhm.
see, I've been on 1 and 2,
Yeah.
with 1, to the left and 2, well, 1 to the left and 2 to the right.
Okay.
Yeah,
Stand up, sit down, fight, fight, fight.
yeah. Ooh, good one. Yeah, and then, I've received some downright, uh, silly ones that I just can't, believe I got on my desk, okay? But as an example, here's one I got. Now, wait a minute. Look at this one on the left here. Look at this one here on the left. Okay. By golly, that's a car.
It
Okay.
sure is.
And
A
that's a
red
car
one.
in a parking
Mhm.
lot. And this is also in a parking lot. But wait, there's more parking lot. What's going on here? Okay. Here's a close up of that red car. Okay. Here's
Wow.
arrows on the parking lot. So this looks like some type of photographic error, doesn't it?
Yeah, Photoshop or
Or,
something.
yes, or
Mhm.
some type of photo hoax,
Right.
right?
Photo
Yeah,
hoax, yes.
like a photo
Mhm.
hoax.
Yep.
Now, MC Escher was famous, as people know, for painting these diagrams or these images, that he did a lot of pen and ink, okay? And he did these diagrams that were impossible. Like, you start with water flowing, it goes to the right, then to the left, then to the right, then to the left, then to the right, and comes right back and starts from where it started. Wait a minute, how'd that happen? And you got to put it together. And by golly, by messing with certain vertical columns in his
And
building structure,
perspectives.
yes, yeah. So you end up getting this weird perspective thing.
Is that where
Uh,
he lived, Mark?
yeah, he was on the building.
He lived there. That's what inspired him to do all his drawings.
MC Escher, I think was I
Strange
forget where
gravity.
was he like in Switzerland or was he Swiss? I can't remember.
Oh, I'm sorry, I can't remember. I
I
should
don't
know.
either.
It
Yeah.
doesn't matter. We're just kidding.
Yeah. So good it could have been bad stitching of imagery. I mean, maybe, right? But it's a weird
Mhm.
you don't see that as a satellite image right there. Okay. You don't see a car from the side in a
Right.
satellite image. So that
Mhm.
already is starting to look odd. But we do know that we get some strange perspectives, like right here. Look at this building, okay, and then look
Oh.
at this building right next to it. I mean, they're like at odd angles. They'd be tipping over if this was
Earthquake,
yeah, right,
earthquake.
right,
Oh my
exactly.
gosh.
And then this one's going the other way. What happens is
Wow.
from the first pass, okay, the plane saw this, okay, this side, and then it made another pass and saw this. But it was on this side when it took this shot of this building. It was on this side when it took the shot of this building. So when they stitch those together, you got this odd confluence of perspectives. So could that be somehow what we're seeing here? I don't know. No matter how hard I try, I can't imagine seeing a car from the side like we saw here. Okay, you see the car
Right.
looks like I can't imagine that. So I don't think so. I think that you know none of that really foots the bill. So I think
Unless
yeah.
unless the new AI is using the Google cars and stitching it together with these satellite images and putting them in there.
Well, now you're talking
Just
dangerous.
oh, just I dangerous, but
That's all
just
right. No, I don't know. I don't know.
mhm.
But so I had to figure it out. And I was laughing the entire time I was doing this because this is as I discovered, okay, this is what I figured out. Look, it was a
What?
car on the side of the building.
Oh,
it
that's
was a
a good one. That's a
it
good
was a real car on the side of the
one.
building because sometimes a car on the side of a building is indeed a car on the side of a
Yeah.
building.
It's like it's parked there in one of those spots.
I know, right? Yeah,
Mhm.
it's like that's exactly what it's supposed to be, or it's backing
Yeah.
out, or pulling in.
Yeah.
Yeah, it's kind of weird. Yeah,
Funny. Who would have thought?
yeah.
Who would have thought?
Well, hey, thanks a lot, Trippy.
Hey.
Yeah, yeah. So yeah, so that was the crazy parking. Okay,
That was a
so
good
this
one. Okay.
yeah, and now we're
Glad it
gonna
wasn't my
go.
car. Okay.
Yeah, yeah, and now we're gonna go to Mexico.
Okay.
Okay, and see and when we talk about Mexico, right, we look at, okay, this is the Mexican border with Texas. In 2006, this is what it looked like right here. This is
Okay.
now Google Earth. Okay. That's exactly what it looked like. All right. The Mexican border. All right. Now, in 2014, that same Mexican border looked like this.
What?
Yeah.
Is that water?
Well, yeah. I mean, you got the Rio Grande in there, but it's all weirdly
It looks
shaped
like
and
it's a
screwed up, isn't it?
it looks like it's a beach.
Yeah. I mean, look at how torn up and tragically wiped out this is. It looks
Oh
really
my
terrible.
gosh, what
So the
happened?
question is exactly what happened. So the question is, what could cause this? We know about rock strata that can look this weird
Pretty.
way. We've
Mhm.
seen this; it's beautiful. Okay,
Gorgeous.
but this isn't that. It's something else, right?
Hmm.
So I had to figure this out. So I started consulting the historical data within Google Earth, especially the dates. And I started to
Okay.
look at other trends, things happening along the Texas border
Mm.
at those different times. It turns out that the river, you can see changing direction many, many times. It went from being a relatively straight run to changing directions like crazy. All right. And as it turned out, I had to think, well, was this major flooding in the Rio Grande or
Right.
something? But
Right.
looking at this stuff over here, I began to. I mean, anyone who knows imaging science recognizes this as digital manipulation.
Mm.
So this looked like the data was corrupted in some way. Well, it was. Upon closer examination, it turned out that these swirls, which disturbed me,
Mhm.
um, if you look at the way 3D things are represented, here's a bridge crossing a river. Okay.
Okay.
Okay. Here's cars lining up at the border. And as they go to cross, well, the bridge is suspended over the river, obviously.
Right,
However,
you'd hope, yes.
yeah. However, this bridge, if you look at it from the side in a three-dimensional application like Google Earth, this bridge goes steeply down to the water level, comes across the water at the water level, then goes steeply up the other side. It's actually it's also a gentle arch going over the bridge or over the water. So bridges and things that are elevated aren't represented well, right? So in other words, the 3D imagery can be distorted by the 3D reality can be distorted.
Right, I guess.
Yeah.
Mhm.
Yes. Believe nothing you hear and only half of what you see. Okay. Hopefully this half. Thank you, Daisy and Zoe. Yeah. So what it means is that these digital distortions were truly distorted in some way, but it turns out they were meant to be. They were digitally changed on purpose.
Well, that's the border, right?
That is correct. So why
Mhm.
would they do that?
It has to do with crossings, illegal crossings would be my guess,
And
right?
your guess is 100% correct.
Mhm.
They were to keep illegal aliens from finding paths across the Rio Grande
So they would use this to look and say, "Oh, that's a good spot to go to."
because illegal
Oh,
aliens were able to use, yeah, Mexican nationals,
makes sense.
Colombians,
Mhm.
they can use Google Earth too. And
Of
so
course.
it was distorted intentionally, okay, so
Ah,
that they couldn't find an easy way to cross.
do you well, that leaves me to wonder what else has been distorted.
Yes, very true. Okay, well, if you think about it, right?
Mhm.
Okay,
Yeah.
there's a couple of major crossing points, right? There's crossing points in Arizona where you live.
Yep, there
Okay,
are.
yeah,
Yeah.
you have Luke. Was it Luke, Arizona, where there's a major open crossing point? No more. That's been shut down. But other crossing points down south of Sierra Vista and other places like that. But now
Mhm.
we've got some wall there. The thing is interesting is that these crossing points actually were um, well, how do you say this? They were um,
Opportunities?
no, they were set up to constrict the flow
Oh,
to actual legal crossing points. Okay.
right,
And
right.
it worked for a lot of this because they could otherwise go to the over there and say, "Hey, let's go and look at the historical data on the Rio Grande find out what time of the year it's the lowest in this particular area, because that looks like a good place to cross. And where they could see gravel on the surface, they'd say, aha, the water is probably going to be low in April, okay, or March.
Interesting.
So we'll go there and cross at that point during those months. I mean, that's how it works, you know. I mean, unfortunately,
It is.
yeah, yeah. And the thing is, when we say the term illegal aliens, I mean, yes, I agree with Sally Forth. You know, calling humans illegal doesn't really sound right. Okay, all we're saying is they're illegally entering the country. That's really
Right.
what the humans aren't illegal. The crossing is illegal. Okay, and we can't support all that. That's the whole point. You know, our tax dollars barely support us, so we have to do something about that. So, and by muddying this border image in this image, what's happened, that actually saved a lot of lives, because they would try to cross at some of these places that Google Earth looked were fine, but the water level might have been too high when they tried to cross, and they didn't make it. So if it's messed up like this and they're forced to regular ports of entry, at least they have a better chance of surviving when they do
Right.
cross. Yeah, you know. So yeah, it's a tough nut to crack. All right. So
Cool. Well, that's a good one too. Awesome.
yeah. So here's another one which is actually kind of cool.
Okay.
And there was one I did where which I did not include in this talk, but I'll talk about it now. There were these missiles being set up on an island in the South China Sea, and the Chinese were saying that these missiles were not long range missiles of any kind. And I looked at the case and I looked at the missiles being set up. I was able to identify them through the high resolution imagery that I was provided. And
Wow.
not only were they long range, okay, they were in striking range of Taiwan. And I mentioned it live to the world, right? On I think it was on the show What on Earth, and the Chinese were forced to remove them.
Oh, way to
So
go.
yeah, well, I hope I'm not on a hit list.
Mhm.
But
You got a
uh,
long-range missile pointed your way, Mark.
well, yeah, or just an angry Chinese guy who's
That's
made it into the country.
more
All
like it.
right,
Yeah, I hope not.
yeah. But bottom line was that they didn't count on being caught. They tried to disguise the missile batteries, but I raised enough questions, and the way I caught them was by the number of power lines that were visible. The missile launchers were kind of shrouded, but the power lanes were visible. And I knew that there were three sets of power lines. One was for the missile guidance, and two were for the missile launcher. And the two were going off
Mm.
in one direction, and the third one was going to what's called a director, a location that was going to actually, decide on the target and send it to its target. So looking at that, I looked up, what type of power lines. I estimated the size of the power lines, how much power they need, whatever, blah, blah, blah. And I figured out that the missile was probably this particular one. It turned out to be that one.
Wow.
And when the Chinese were found out, they had to remove them. And I don't think they were too happy, because it cost them millions and millions to get them there. And they had to turn around and take them back. It's like, that's right, you guys, play fair.
Well, they're
So,
probably not that happy anyway, so.
yeah, I know. That's true. So, this one, Mini Milky Way, this was fun, because this was another one of those cases, like with the Chinese, where the results turned out to make an entire country really mad.
Oh.
Okay. Well, I should say, you'll see when you hear it. I'll tell you the story. But this is what was seen. Now, this is a photo taken from the International Space
Oh.
Station. This is an actual photo. And you can see there's some dark lines in here. These are the contrasty lines. And what are those? And what are these? Now, the ISS was taking this picture. I had people saying, that's a star cluster. No, trust me, the number of star cluster images I've taken, this is not a star cluster. This is something totally different, you know. And it was, Samantha Cristoforetti who actually took this image, and it was taken looking down at an area near the Falkland Islands. So now I had to figure out what the lights were on the sea. I noticed the color of the lights. Some are green, some are bright like sodium vapor, reddish, orange. Okay. And so now the speculation went on. Yes. So was, so some said, was it a city and she was just wrong about where she was looking? Well, obviously there are, cities, but they're on land, not in the open ocean like this. Okay. So, and our friend, Karen Belmont says fishing boats. Michael Hedrick says bioluminescence.
That's a good
Yeah,
one.
no, that's a good one too. Yeah, absolutely. But
There's
as it turns out, phosphorescence from Donald Kunzer. So that's 2 for phosphorescence. Okay. Well, the bottom line is this is again out in the open ocean, and so bioluminescence is on the table. Phosphorescence was on the table, and it was for me when I did the analysis. But then I started to notice that bioluminescence doesn't come in many different flavors of light. The light is usually a yellowish green, and these lights here just negate that. So the other thoughts, and the network asked me to consider the following. They said, well, could it have been an ice festival?
Oh, pretty.
Could it have been a festival of lights somewhere? And my answer was, well, yes, except for one problem. It's in the middle of the open ocean, and the temperature was well above freezing. It was 46 degrees.
Ooh,
Okay. And so it's mild, non-winter temperatures. Okay, so it's not an ice festival, which do look like this, by the way, from above. They have some rectilinear features too, because they make these buildings that are long and things. They're really beautiful. All right. So the question is, what about ice pillars seen from above? That's what one thing someone said. Now, right away, as a science guy, I said, well, you don't see ice pillars from above. Why is that? Well, because they don't work that way. Let me show you how ice pillars look. First of all,
pretty.
okay, yeah, okay, and they're gorgeous. Okay,
Ooh.
but I want to show you how they operate and what you actually see. Why do they look the way they do? Well, this diagram shows you how it works. Okay. Now, if you look on this side, here's what people see. They see this ice pillar going straight up. That's what they see visually. What they don't see is that much closer to them and at various levels in the sky, ice particles are refracting the light seen from down below back to their eye. And so if the conditions are just right, you have all these layers of ice crystals, and the light is going to get refracted back to your eye, okay, at a complementary angle, such that you see the virtual image of a tall spire, but in fact you're just seeing the reflections or refracted light through the ice crystals that are between you and the light source far away. You might not even see it. You might not even see the light source, but the crystals in the sky probably can. So they're going to be much closer to you. So ice pillars are a phenomenon that is local. If you move 500 feet to one side or 1,000 feet to one side, they'll change because you're seeing them through different ice crystals. All right. So it's a very different thing. So from above, you wouldn't see an ice pillar because this image here isn't really there. It's a refracted image from these crystals here. Okay. So there's nothing to see from above other than just the light. Okay. So after some digging, I actually started to think maybe we're looking at a shrimp fishing fleet, because shrimp fishing fleets use these lights to attract the shrimp.
Yep.
And so the question was, is this what we're looking at? So with a little more investigation, it turned out this was an illegal shrimp fishing fleet.
Of course.
And they were out in international waters. So once again, they were caught.
Seems to be a pattern with your investigation.
I hope not. I got to be careful. So for those that thought bioluminescence, like Donald Kunzer, Tricia Ferreira, come up with some good ideas.
Yeah.
And bioluminescence is something that's really cool. All right. But we don't actually see, a tremendous amount of bioluminescence from space. Okay, the bioluminescence from space would be too dim. So Michael Hedrick says many buoys. Yeah. Well, they're actually the very, very bright lights on the fishing fleet, and actually you're not looking at the light that's aiming up into the sky. You're not looking at the lights
Right.
on the boats aiming up. You're looking at the light reflected off the water because they're
Wow.
aiming down into the water, and the shrimp race to the light and get caught and end up on your plate. Yeah. Yeah, so that's a pretty cool one. I thought that was neat, you know.
I think I saw that one on TV when you did that one.
Oh
Yes, I
yeah.
saw that on
Okay.
TV when something like that, so
Yeah, yeah. And so
Mhm.
now they were moving through international waters outside of territorial limits, but the
Wow.
problems, yeah, and additional photos showed that they were moving across the ocean at that point and moving to different spots throughout the whole time they were out
Oh.
there. But it was illegally sanctioned. It wasn't sanctioned. Now, if you say, well, wait, they're outside of territorial limits, yes, but they still need to have oversight. Like whalers are outside territorial limits, but they still have limits on the whales they can take,
Right.
right? So same thing with the little shrimps. So it's pretty cool, you know.
Very cool.
Yeah, you know. So I see a lot of people here uh, that are in our Skyter live stream, and I'm glad to see you guys here.
Yep.
Water Rat's here. Water Rat's a friend of mine named Matt.
Mhm. Hi, Matt.
Matt used to work here with me a lot on projects. So yeah, so we got a really cool next one. This one was fun. The rainbow halo's neat because
Okay.
again, from the International Space Station, you get to see some cool stuff. Now, Reed
Great.
Weissman, who's an astronaut on the space station, he took this image.
Ooh.
Okay, now obviously a little blurry. Okay, but again, let's be fair. He's moving at 17,500 miles an hour. So if you're going to take a time exposure of the sky, you gotta push your camera up against the cupola window in the International Space Station, and you have to kind of hold still. The slightest movement's going to blur the image, and if you're moving so fast, depending on which way you're aiming your camera, you can get a really nice shot or one of these shots, where it's a little bit off. Now, this stuff here, these aren't UFOs. These are pieces of the International Space Station's panels itself that are sticking out. Okay. They stick
Oh,
out. You see them out of every window, almost every window, because they're a very, very broad size. But the thing that's
wow.
important here, what we're looking at is, the interesting colors down below. Now, this isn't sunlight aiming at something, right? This is on the night side. Look at all the stars in the
Oh,
Milky Way. I mean, it's really beautiful.
yes.
Okay. Yeah. Now, see, this is an example. When you actually aim outside the window and you expose a long exposure, okay, on the dark side of the earth, what's looking down below, he probably couldn't see any detail down there. But
Hmm.
by overexposing the view to show the night sky above and this fairly faint band here and this yellow and green one, to overexpose this stuff means that the earth starts to look brighter. Okay.
Right.
So the stars are definitely out there. Okay. So this is interesting. Now, the question is, what are those colors? You know? And so I was asked to figure out what the colors are. And I'm familiar with in astronomy as an astronomer, I'm familiar with how the molecules operate in our atmosphere. And I'll tell you all about those in a minute. But the first
Ooh.
thought is, was this orangey color here? Okay. One of these red auroras.
Ooh, that's
Now,
beautiful.
yeah, now there's many high altitude auroras that we see, and they are red. And the reason is because they are oxygen. The oxygen, atoms in the high upper atmosphere, their interaction with the solar energy that's entering our Earth's atmosphere from the sun, the solar wind, will generate a glow. They'll glow and they'll glow red. That's one of their atomic transitions that the oxygen atom goes through. And, you know, you also get different colors depending on where you are in space. At very high altitudes, there's very few oxygen atoms. And in those high altitudes, we actually get this incredible red glow because certain transitions of the electrons within an oxygen atom, when it hits and receives ultraviolet energy from the sun and high energy particles from the sun, the electron is energized and it starts to go higher and higher in its energy state within the oxygen atom. And when it gets really high, it could leave the atom for a period of time and go, I'm free, I'm free. I'm free, I'm free. And then
run away, run away.
run away, run away. And then it falls back into the atom at one point, either this the one it came from or another one. But as it falls in, it cascades down in energy levels. And as it does that cascade down, it gives off energy that it had acquired on the way out. Okay, so it gives off that energy. Well, the predominant energy that it gives off is red light in this particular part of the spectrum for this particular transition in oxygen. And it happens at very high altitude. All right. So that's a red aurora. So is that what this could have been? This orange band here, right? Could that have been this? Well, it's actually rare. Okay. And here's some other ones, and they're usually associated with green auroras, but I have seen just red ones. I remember in the mid 80s, I actually saw auroras like down here in Connecticut.
Oh, pretty.
Okay. And then by the evening, I had a red aurora like this that went horizon to horizon. I was literally underneath a reddish pink bowl. It reminded me of that. It reminded me of that Star Trek episode, "For the world is hollow and I have touched the sky."
Oh, I was thinking Twilight Zone, so yes.
Okay, yeah, fair enough. Yeah, so I started off thinking, well, is it a molecular energizing thing? And that's what they asked me to find out. Now, going into it, being an astronomer, I sort of knew what it was, but I had to go through the rigorous analysis, and I had to justify every statement I made. I had to justify with some science, and that's fine. I don't have a problem with that. It just keeps my mind sharp. Okay. So but the thing is, okay, the auroras for oxygen are really red. Okay, they're not going to be orange, and you might get a little pink or yellow, but they're not red. Okay, in other words, the glow we were seeing, okay, wasn't the red of the oxygen. It was. You don't get the orange, pink, and yellow that we're seeing in this image from the ISS. So I dismissed the auroras, and the thing is, these are called the auroral ovals. Okay, the one on the left, the green and the red. Green these are probabilities. The green is a probability that you'll see an aurora in that circle, and the red is a very high probability that you'll see it. And then on the South Pole, okay, you actually see the auroral oval there. That's Antarctica right here. Okay. Wow. Yeah, this is Australia here. So here's
the real one you said on the right.
That's the auroras. Again, this is gonna be time lapse, and they're always moving, so it's gonna be a little blurry. This is just a probability. This is not the actual photo of the auroras. Okay, so this is the northern auroral oval, and this is the southern auroral oval. So we have the aurora borealis for northern, and aurora australis for around Antarctica.
Cool.
Okay, yeah, and in times of heavy activity, this auroral oval can extend way down here. Okay, we're right about here with our observatories in Arizona. I'm actually up here, and you're down here too. Right. Okay, but down here, we actually had this auroral oval going right over us down there, as you did, and so we actually photographed with our all-sky camera. We saw auroras for the first time in our camera down here in the Sonoran Desert. It was the most beautiful and odd thing I've ever seen. Yeah, So so again, the colors weren't right. There were no red auroras. That wasn't red that we're looking at. Okay, Here's another view that incorporates auroras and this additional glow. Here's the auroras here. There's the oxygen aurora. Okay, let me go back. Here's an oxygen aurora right here. Okay. Here is a green aurora. Okay, that's mostly due to oxygen and nitrogen. Okay, but then down below you have this band, this reddish band. That's not the surface of the Earth. Earth's surface is down here. This is atmosphere we're looking at here.
So it is atmosphere. Okay,
This
all
is
of
from
that.
here all the way to here. Okay, this is atmosphere. And so we have this orangey band, we have this light greenish band, then we have a little bit of this red out here, but then that's mixed in with this red here. So the question is, what are we looking at? Here's an astronaut in the cupola. He's looking right at us. That's scary.
Fun.
He's spying on me.
That's
Okay.
cool. Lucky.
But here,
He's lucky.
I know, right?
Oh man. Yeah.
Yeah. So we have this red layer, okay, which is very faint. Okay. Then we have this green layer. Okay. And in this green layer down below, we also have this yellow layer. And then we have the atmosphere down to the ground. Okay. So the question is, those aren't auroras. And this is the night side of the Earth, right? We expect to see auroras at night. However, this is pretty constant brightness all the way around. Auroras are they come and go. This is constant brightness. So why is this constant brightness? That's the other thing. And it's not just seen in photos from space, it's seen from the ground as well. Here at a dark sky location, a time exposure reveals a green glow throughout the image. You see this green? Yeah, that's weird. Yeah, that's not light pollution. Okay, that's something else. And then here, out at Mauna Kea in Hawaii, okay, where the sky is ultra dark, we have this red glow. See that? Yeah, we have the southern Milky Way and a little bit, and then we have this red glow.
Hey, Mark.
Yeah.
Could it have anything to do with fires? Because when there were fires in California and Arizona, the sky was orange for days.
It was.
It had this orange, just eerie feel to it. All the time. So that's kind of when you look at that, I was thinking maybe volcanic, fire or something. I don't know.
Yeah. And the only difference is that stuff you're talking about, that was only a few thousand feet up in the atmosphere, maybe 20,000 feet. This is 100 miles up.
Oh, big difference.
Yeah, it's between 80 and 100 miles up. Okay.
Okay, cool.
Now, but the fire, what that does is that puts particulates in the atmosphere, and those particulates are very, very good at sucking up some of the additional light coming from the sun, specifically in the blue arena. And so that's why the sun always looks a little yellower and very, very, very deeply red at sunset and sunrise when you're in fire season, So, but yes, so the question is, what is this, right? What is this?
I don't know.
I know it's something, but the bottom line is, once I started to put together all my analysis, I started to realize, okay, I have a feeling I know what this is. I always felt along the way that this is what this was. I'm going to try to now justify it. I wrote a justification. It turned out that it was good. It's called airglow. Now,
airglow.
Yes. So I identified all the different levels here so people could
see. Did you
see.
make that up?
I did not.
Okay.
Yeah. You'll see here the Earth on the right here. This is part of a peninsula. There's lights on the ground here, right? And this is at night, and this is a time exposure. So we're getting the Earth looking brighter because we've time exposed that. Therefore, you see the stars as well. You'll notice this yellow layer. Now, is that light pollution or is that smog? No, it's not. We're looking at sodium atoms, okay? And I'll explain in a minute. And then we're looking at molecular oxygen, O2, okay? Which is right here in the green. Then we're looking at the individual oxygen atoms way up in the upper atmosphere that have been separated from other oxygen atoms with ultraviolet radiation bombarding them and separating them. Okay, and that's the red glow. So what is this stuff? Well, during the day, okay, the sunlight beating down on the Earth, it's doing this to the atmosphere all during the day. And the oxygen atoms are getting excited. Their electrons go up off the atom, and then when they come back down, okay, into the atom, and the molecules, the O2, the diatomic molecules, they give off this green glow. Okay. Then they also the single atoms of oxygen in the way high atmosphere, they give off a red glow when their electrons go up and get excited and come back down. Then sodium atoms do the same thing. Okay. So what happens is all during the day, these atoms and molecules are being charged up with this stuff. And it takes some time for it to go away. In fact, it doesn't go away. They remain charged enough so that all during the night, at one time or another, you're going to see this glow around the earth. And that's the glow of the air. It's natural. It's not pollution. If anything, it's a bane to astronomers because they have to, if you're photographing a red nebula and you've got this additional red glow, now you got to know what's nebula and what's glow. And that's part of the problem. Yeah. See?
I didn't realize there was so much sodium in our atmosphere.
Exactly. There is. Yeah, there is. Okay. And we have a love affair with sodium. Sodium is Na in the periodic table, right? The N and the A.
Right.
And I showed you this before, but today I got my wonderful periodic table of the elements. And I'll show you real quick here. It may not. Let me just see if I can. Yeah, there we go.
Flip the box over. Flip the box over.
I like that.
Oh, can you see it okay?
Oh, sorry. Yeah, you're right.
Yeah, there you go.
Yeah.
There you go.
So this is a periodic table, and it has all the real elements in it. So there is a piece of sodium up in there. Okay.
Salt?
Yeah, right. That's not salt. Okay. But we have actual stuff. And if you look at it from the edge, okay, you can see the elements suspended.
Oh, neat.
See them? They're suspended in there.
Yeah.
Yeah. Here, let me take out plutonium. I'm just kidding. They don't give you plutonium.
Is that real heavy?
Yeah, right. Yeah, the lead sure is. Yeah, no. But the bottom line is that, okay, we have a love affair with sodium. We've always had a love affair with sodium. It's essential to our survival, right? We use it. We're salty, which remember salt is a sodium atom, which is Na in that periodic table, and chlorine, which is a Cl. So NaCl, that's salt. Okay. Now, a salt is defined as more than just sodium and chlorine. There's other salts, okay? But sodium is a very common element that gets washed off of continental surfaces by rains, goes into the ocean. Sodium and chlorine interact because one atom needs an electron and one has an extra one to give. So that's
convenient, yeah.
And so like, and they link up. They link up, and you have sodium chloride. And so that's that's the basis essentially of the salty ocean. And when we evolved out of the ocean, we took a little bit of that salt with us. So we have a few percentage points of salt in our bodies, not as much as in the ocean. And if you need to know what that is, all you have to do is lick your forearm when you're sweaty, if you dare, then go, ugh, but then you'll taste salt, okay, because it's in there, right? And it exudes out of your pores, right? So salt and sodium are ever present in our atmosphere, ever present in our rock strata and everything. And I want to bring this up too. Donald Kunzer asked, so is that what they call the green flash? I think he's talking about this. The green flash is actually, the green flash is actually an effect you see when the sun sets, and it happens just at the right point where the sun sets. You'll see that green flash in the sky. All right. Now, where's that green flash coming from? Well, it's coming from these interactions we're talking about. Okay. But this glow here we're seeing, this is a glow of the molecules directly in the atmosphere, and that glow is from these energized atoms that keep giving off this light. Because the Earth goes around every 24 hours, 23 hours, 56 minutes, and however many little seconds, right? But in that time, it's not enough for the atoms to give up all that energy. If the Earth rotated a lot slower, then maybe those molecules would give up all the energy and it would be truly dark at some point. But it isn't. It isn't yet at this point. We don't have a
Good question.
We don't have a slow day at the moment that's slow enough. Now, our day used to be much faster. When the moon was closer to us, okay, the Earth was, well, the moon was actually easily twice the size it is now in our sky, and our day was 4 hours long. So, I mean, that's pretty cool, huh? You commute an hour to
Really
work.
fast.
Yeah, you commute an hour to work. Whoa, you know, and then you got to work for a half hour, and then come home and sleep for an hour, and then go back to work. So, it wouldn't work for us. So, as the moon is rotating around the Earth had this tidal bulge, and the tidal bulge lags as the Earth rotates and goes around. Okay, the tidal bulge lags a little bit, and it ends up leading, and so that tidal bulge sticks out a little bit and tugs on the moon out here, just a little bit, and so it makes the moon accelerate a little faster in its orbit. And so as the moon accelerates ever so slightly with every single rotation of the Earth, okay, it actually is getting faster and faster in its orbit, and the faster an object moves in orbit, the farther away it gets. So the moon is actually kind of spiraling away from us. And I'm not going to let this show spiral away from us either. I know we have a minute to go here.
No, actually, it's time right now, I think.
Is it? All right. Well, okay. Well, we'll talk about the spiraling moon when we come back, and we'll pick up right there with our glow. We'll be back in a few minutes.
As UFO reports come in from around the world, the Mutual UFO Network, MUFON, is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you'd like to be part of our investigative team, you are always welcome. What could be more exciting than exploring the UFO question firsthand? Join MUFON, find your friends.
Are we back? Ah,
We are back
hello again, everybody.
for more good stuff.
Yeah, more good stuff. More good stuff. Yeah. So, we talked about this airglow, but I want to show you a little bit better way.
That's pretty.
Yeah, you can see here in this layer diagram. Okay, we start to get that green line airglow at around 50 to 100 miles. Okay, but the atmosphere doesn't just stop there. There's an ionosphere, and up there, okay, above that, okay, is the famous Kármán line and all that. That's the line that differentiates space from not being in space. And so we get a UV airglow, ultraviolet airglow up there, but we have the red and green, all right, and the sodium is down a little bit mixed in there. You can't really tell, but this airglow is there all the time, and it's actually very faint. You can't see it unless you're at one of literally the darkest spots. Now, at our observatory sites, I think I've seen airglow, but it's very faint, hard to capture. It's just a generic glow, so it's really hard to see. But the two sites are actually quite dark. The clouds are dark against the stars. That tells you how dark it is. It's pretty nice. So airglow was what we saw there in those images with the layers like that. All right. Now, again, you look at this image of the Earth, you say, well, where's the airglow? Well, it's not in this image because I actually made this image. This isn't the real Earth. That's a computer-generated Earth that I made.
Oh, faker. That looks real.
It is. It looks very real.
Mm-hmm.
I even used physics to determine, the edge of the Earth here to make it look very real. But I did not include airglow. I probably could have figured out a way to stick airglow in there. But for airglow, you need to basically be in the dark side, and I didn't do dark side stuff.
And there has to be an atmosphere, right? Otherwise, you'd see it on the moon.
That's correct. Very good point. Yeah. Yeah.
Okay.
Yeah. Yep. So, interesting thing, other like the moon, people say, well, it doesn't have an atmosphere, but it's actually not true. The moon does have a vestigial, tiny atmosphere, and it's there's a lot of sodium atoms that are floating around the moon, which is kind of interesting. Yeah. Yeah. So now this is another one. This was kind of fun, and it's called Plain Stupid. Okay. Yeah. Now here's a shot of a lake. Now this is in 20. This is true. Someone reported that a plane was in Lake Harriet in Minneapolis.
It looks like it.
And they called and they reported this and said, I think there's a jet plane in Lake Harriet. Okay. And when they went out there, of course, they didn't find the jet plane. So they asked me, what is it? And I'm like, well, okay, let me take you through it slow. Okay. Again, Google Earth takes pictures of the terrain down below. Okay. And the thing about Google Earth is that it can take pictures of very real aircraft sunk in the water like this.
Oh, yeah.
And like that. And like that. Actually, I remember that accident.
A good one. Wow.
Yeah. And that one. Okay. Those are real planes in the water. That's right. But then now what happened here? Well, usually when a plane crashes in the water, it sheds a lot of its pieces, right? The wings come off, that kind of thing. It breaks
perfect shape there. Nice straight edges. Mm-hmm.
Yeah, a little too perfect, isn't it?
Yeah.
Yeah, that's correct.
Well,
so what happens is Google Earth actually stitches photos together. And if in one of those photos you have a plane coming through that you capture on your image, when you go and you take another photo of the same area the next time, well, the plane's not going to be in that image. So what you're going to get is an overlay. You're going to get the overlay of the water and the plane that was previously there.
Love it.
And they're going to mix with each other. And that's what we're seeing here. Okay. And that's one of these artifacts from the stitch. Okay. We also see things like this where we see, remember, a satellite's taking pictures with an RGB sensor, red, green, blue. Okay. And if the plane is moving through the field and is taking a picture, well, sometimes you might see the separation between the red, the green, and the blue. And in this case, we do. Okay, we see that over there on the right side. We see that color aberration. Okay. But we also see things like we saw here at Lake Harriet. We see ghost planes, and here's a ghost plane. Look at that. Okay. In this particular, there was a plane at this gate here, and then there was no plane. Like,
it took off.
Vanishing slowly. The Langoliers are eating the plane. Okay. Stephen King would be happy. Okay. Well, the fact is, of course, that in fact, this particular case, that's not really what is happening. Okay. What's really happening is that the plane was there in one image, not there in another. And the images kind of started overlapping from like about here, from here down, and then from here up. So here down, they were mixed together. Here up, they hadn't been mixed yet. Or the plane was actually the image that this swath had not yet been done. So we see a half and half image. That happens fairly often. Yeah, pretty cool.
It is.
Yeah.
It makes you just want to go cruise Google Earth and look for stuff like that.
Oh, there's people that do that.
Yeah, that'd be fun.
Now, Google Earth used to have a much higher resolution. And when they started to realize we're running out of server space, they actually down-resed and down-sampled a lot of their imagery, all of their imagery, except for people that pay big dollars. Okay, they can actually afford the servers. And you used to be able to zoom in and zoom in and zoom in and zoom in. And quite frankly, they got rid of that because it was before they had the blurring technology. So there was this one poor woman in Norway that was sunbathing on her porch. And she was without any clothes on, and she became an internet sensation. And people zoomed in all the way, and they could see her in all her glory. Okay. And so when she complained, they just removed that frame until they could replace it with another capture, which they did eventually. And she was inside for that one. But I remember seeing that, and
perfect timing, huh?
Perfect timing. That's right. And people said, well, I don't want to be seen. And so they started writing an algorithm that would also remove them from Street View. And that's why now when they show license plates, they're all fuzzed out. They show a person, they're fuzzed out. They never were used to be. You can actually see the person in ultimate detail, So they had the data's all there. Okay. It's just, unfortunately, they didn't have the server space to do this for nothing. And that makes sense.
Yeah, it does.
Yeah. So, so we get strange images off of there. Here's another one, another aircraft that's in the water.
It sure looks like it.
And remarkably intact.
Yeah. That's the sign.
Yeah. And the other thing too is here's some boats.
Huh?
Yeah, I know, right? These are all boats that are there too. Now, what's going on here? See, this is a sailboat. You can see the mast sticking up.
Yes.
Okay, here's another one, another cabin cruiser
Must
here.
be a time-lapse photograph, right?
Or multiple. Aircraft aren't the only oddities. Okay, but again, these things. Let me do this. Okay, before I show that. Okay, if you look at this, here's one of the images, and then when it did another image, the boats had shifted in the current. And that's why they look like they're moved around a little bit. Okay. And so the boat moved from here, spun around to here, and never went back there. So the ghost image is all that remains.
Yeah.
Okay. But it took several shots. So the boat is at what's called a mooring. Okay. You can see the mooring here. It's a mooring line. It's out in the water. It's tied to the ocean floor or the river floor. And the boat just sits there, and as the current shifts, the boat moves around the mooring, but it stays relatively still. This boat here's its mooring. Notice the mooring is solid, hasn't changed.
Right.
Okay, but the boat has against it. Solid mooring, but the boat has changed against it. Okay.
Yeah.
So again, the mooring line, the mooring buoy stays right where it is, and the boat sort of dances around it.
Yeah.
And if you take multiple shots of the same scene over and over and over and stitch them together, this is what you can get.
Yeah. I agree with Genghis.
Yeah.
Yeah.
You could have told me there was a swarm of moths by a porch light. Yes, that's actually what it really is. No, I'm just kidding.
It does look like that.
It does. It does.
Mm-hmm. That's
good job, Genghis. And then, of course, there's this one. And in fact, this is actually really there.
Huh?
Yeah, this is really there. This aircraft in the forest is someone's house.
Oh, cool.
They had it assembled here, and they made it into their home. And it's the coolest thing. I've seen it.
I bet. That's neat.
Yeah. You can actually go on YouTube as well and see it. It's pretty cool.
That's awesome.
Yeah. Now, we also have like unidentified floating objects. And I was like, wait a minute, what are these things? Okay. What can these possibly be? Yeah, I'm sure you'll be intrigued. Okay. So it starts off by looking at this picture. So I want everybody out there to look at this picture and find the thing that shouldn't be there. So we have a few people watching.
Tick, yep.
Yeah, tick, ding, ding, ding. It's still your turn. Okay. So tell me what you think doesn't belong there,
Well, it's something I'll to give him a hint, there's something very colorful that sticks out to me.
Yep. For sure. That's for sure.
Yeah.
I probably won't wait for anyone to answer, okay? Because that's probably not gonna, we got a lot of people watching, but to write something, they might not be in the ability to do it. It's this boat right here. No, I'm just kidding. Yeah, Donald Kunzer says yellow. Sky is in the house. Oh, let's go. Yeah, that's Evan. Hey, Sky. Hey, Evan. Sky to Life fan. Thanks, brother. Yeah, no, it's this thing right here. Okay, and this does not belong there. Okay, one of these things is not like the others. One of these things just doesn't belong.
It looks pretty small, but then it looks huge scale wise. So it's hard to see what it is.
Yeah, so you may not know what it is, right? Okay, but it looks like a giant rubber duck.
Yeah.
Okay. Now, is that an illusion? Well, it led many. I think it was a hoax, and I was thinking, okay, I'm gonna analyze this thing, trying to think, is this just a Photoshop hoax? I mean, because that's the kind of thing I would do just for fun.
Put a duck in the water. Yep.
Well, not to try and fool someone, but just to. I mean, it's a relatively easy one to do too. It's a real easy one to do as long as you can match the sun angle. You could take a photograph of a rubber duck, stick it in there, fuzz it up enough so it looks like it's part of the picture. In fact, I made one, and I put another rubber duck like down here, and it looked just like that one. So I thought, well, maybe this is a hoax. But then I started to think, hang on, this is not right. I remember something about this Hong Kong thing. And it turned out that sometimes the truth is stranger than fiction.
Oh, my goodness.
This is a real giant rubber duck.
That thing is huge.
Yeah, it's a big inflatable. You see the seams here? Yeah.
Okay. Yep.
It's just an air-filled, not helium-filled, but just an air-filled one like this. Donald Kunzer says there was one on the Delaware River. I bet you he's right. Yeah, I bet you're right, man. Yeah, but see, that's kind of cool, I thought that was pretty cool. And so
that's really fun. Someone has a sense of humor.
Yeah, someone has a sense of humor.
Oh my gosh.
Yeah, this is dangerous though, because these rubber ducks could end up getting eaten by sea creatures.
Yeah.
And that's a problem. So you have to make sure you grab them all. You know what I mean?
That's such a beautiful picture. It reminds you of the pink flamingos, just all the birds.
Oh, that's right. That's right.
Around, but yellow.
That's right. The flamingos come in and say, yo, this is our stuff here. What are you doing?
Get out of the hood.
What are you doing? Don't you be smiling at me with those sunglasses. What do you think you are, man? With that big old bill of yours sticking out. What are you doing? I have a much prettier head than you do. Your sunglasses are cute, though.
They're fun. They're cool.
That's right. So that was it. Oh yeah, that's right. E.T. phone. You know?
Ah,
Yeah,
that's hilarious.
I thought that was funny. Yeah, so that was the funny stuff. I thought that was pretty cool.
It was cool. I want
Yeah,
more. I want more.
and we'll have another one at some point.
Okay, cool.
Yeah, for sure. I just think that's pretty neat.
Yeah,
So I just want to also make sure that people know where they can find us. We again we're Sky Tour Live. That's what we are. But we also have we're also Sky Tour live stream is on YouTube. It's on Rumble. It's on Kick. It's on Facebook. There's a Sky Tour live stream Facebook group that you can join. If you haven't ever seen it yet, please do. You can join us. It's free, and we actually provide you with incredible and actually really neat, incredible photos that we take
absolutely.
all the time. Yeah, Tara knows,
Oh,
and the reason
beautiful.
Tara knows is for a very important reason, because Tara is part of our nonprofit organization, aren't you, Tara?
Yep. We're all part of that, this whole community. So, but yep.
Yep, you're absolutely right. And I'll just
Mhm.
I'll just show you real quick here because this is kind of cool.
Okay.
I want to just show folks our website because it's kind of neat. All right. So here, if you go to skytourlive.org or skytourlive.com, either one, you'll see our website here. Now, we are a nonprofit. You can support us by donating at one time. You can support us by subscribing and donating. You can join our Patreon, okay, and support us. And if you notice as you scroll down here, and what are we? Well, we're the universe live in real time.
That's right.
Here's one of our streams that we did. This is one that we do, and the typical. This is a moon stream we did. All right, and you got some big mouth down here talking. I guess that's me. All right.
Thank goodness someone's explaining all of that, though. It's interesting stuff. So.
It is. This is our Benson telescope, the newest one that we have get in service, and we just do a lot of things, and we show the different parts. Now, the moon was actually getting clouded out that night, but we were zooming in on some areas of the moon to show some of the craters and stuff. But the sky was very turbulent, but we still managed to do it anyway.
Oh, beautiful.
Yeah, you can see how it's shimmering a little bit. Yeah. And this isn't the only thing we do. Obviously, we do many other objects. We have an all-sky cam, and the all-sky cam has caught some really cool stuff. We caught a re-entering Chinese satellite, re-entering the Earth's atmosphere. It was unannounced, unexpected, but we caught it.
Mm-hmm.
We caught a very strange aerial anomaly where something flew in a tight circle way, way up high, kind of over on this side, way up high, about like that. And this takes frames. The frames that are taken were like 15-second frames. And in 15 seconds, it made a half a circle way up in the sky. And the other 15 seconds, it made the other half of the circle. And that didn't make sense to me, Tara, because I thought, well, if it was a military jet from Luke Air Force Base, for instance, right? You'd see the exhaust nozzle of the jet as it's going away from you, because that's the part you'd see. That's the light coming off the jet. But as it turned around and came at you, you wouldn't see that. So why did I see the same brightness going in a complete circle? To this day, it makes no sense.
You don't know.
No. And there's something else our all-sky camera caught, which is really neat, is we caught something came in from here, okay, came across like this, all right, like that, and then went meow. It took a sharp angle and turned, and it was not an aircraft. I could zoom in on it and see that it didn't have any FAA lighting. It was just a single solitary light. Came from way far. This is the horizon over here, okay, because this is an all sky, so it's a wide angle view. Right. So it came in, went right to here, and then went boom, like a sharp turn off to one side. And that's recorded. That's recorded in our live stream nightlies, which people can get to when they go to our site. So what is that? That's odd. I couldn't understand what that was. So that one and that circular thing, very strange. I don't understand.
So cool.
I don't understand, but I do understand that we've been here for several years now. We've been doing this since 2017. Did you know that?
Can you believe it? Wow.
2017. Yeah.
Wow. That's great. Very
Yeah.
impressive. Good job.
Now, if people want to get pictures, well, you just say go to the online database and you get these folders. We're also working on an application thanks to Isabella Melamed, our Bulgarian. We call her a super fan. She's crazy. She's wonderfully great. And she's making some application that we can, hopefully deploy to iPhones and Android. We have one now that works on the PC and the Mac. And we're just getting that ready. We're trying to get the links to the pictures right. But it's just so easy to use. And you can go all the way back to 2021, everything we viewed.
Wow, that's a lot.
Yeah, well, it's everything from this very, very large directory here.
Wow. Well, you stream often, so
yeah. And this ends here. Let's see. This one ends in 11/8/2021, and that is where it starts, and it goes all the way to 2025 up there. So the Western Observatory started as a trip out to the desert. Okay. As you remember, I believe you were with this trip, were you not?
I probably was, yes.
Yeah. And the whole thing started in the desert in the west of Phoenix by about 75 miles by putting a flag in the dirt. That flag stayed there for a couple months. And then we ended up building a base and filling it with concrete. And then that night,
that's us waving. Yeah.
That's the owner of the land, and that's you.
Yep.
Yeah.
Funny.
And that night I set up my camera tripod on this, what would become the Sky Tour West 1. And we ended up, I ended up taking some beautiful pictures of the night sky. The sky was so beautiful. It took my breath away.
Okay? Oh, it's a beautiful location.
And this is Maddie, Madison, a beautiful little doggy.
She's sweet.
She's been to snake school. So there's a lot of rattlesnakes out here. So if she sees rattlesnakes, she knows how to deal with them and dispatch them.
She's a smart dog.
She is.
Sweetheart.
Yeah. And this is the building of the building.
Oh, yes.
Yeah. I was not here for this one. There was COVID, wasn't it?
Oh, boy. 21, 22.
Yeah.
Could have been. Yeah, it was around that time. Boy, time flies.
Yeah. And you were the one that was overseeing all this construction along with Marianne.
Yeah.
So it was a wooden frame, and then we sheeted it in metal because we didn't want brush fires to take us out.
Exactly.
Yeah. And then putting in the pier for the telescope here.
Yeah. That was an exciting day. Yep.
Yeah. I think these are your feet right here.
Yeah, probably. Yep. That looks like my shoe.
Yep. And there's the completed observatory.
Oh, beautiful.
And this door is, of course, your piece of art you did for us for the door. It's stunning.
Just for fun. Yeah.
Yeah, that's right. Here's the first all-sky camera we had, and I built a second one. Okay. And there's Tara's door.
Yeah.
Now
go ahead. We had some Coke bottles, and we opened them up on that door handle up there.
That's right. Because that door handle is actually a bottle opener.
Yes.
I thought that was clever of her. Yeah. I also left it to her to get the lock for the building, and well, she definitely got a lock.
Yeah, I did.
Like Fort freaking Knox, man.
You never know. That's good equipment in that building.
Yeah, so. Yeah. Now we have an ongoing contest.
Oh no!
Here we go. If you can guess them, these are actual bottle caps, the actual colors. You didn't paint these, okay? So, like an orange drink, she has the orange caps. The blue ones are Bud Lights, I think. No, she didn't drink all this. Okay, it's just that she worked. Where was it? You worked?
I worked at a bar, at a gallery with a bar in it. So
okay.
I just saved them for a few years, knowing that they would come in handy someday.
Exactly,
and they did.
Yeah, this is the Orion Nebula. If you squint, you can actually see the Orion Nebula, and the one that we just took, this part right here, this is Measure 43, at the top side of the Orion Nebula. And then this is the Orion Nebula with its beautiful blue. She actually captured the oxygen glow. She captured the hydrogen alpha glow, and then she captured the bright center. The only thing she didn't put in was the trapezium, but it's in here somewhere.
They're in there, the 3 of them.
Yeah, there's 4. Yeah,
4. Okay, yeah.
But the fact is, okay, if you can guess the number of bottle caps in here, well, you're going to win some Sky Tour swag. We've been saying that for a long time. And so far, no one's been able to guess correctly. Yeah, it's been tough. All right, this is the telescope before we put the dew
shield.
cap, the dust shield on it. Okay. Now, this is the front of the telescope, and this is the camera. So what's that doing on the front? Shouldn't the camera be in the back?
Usually
it is.
Yeah.
But we modified this telescope, which was running at a photographic ratio of like f8, okay, or f10. And it now runs at a photographic speed of f1.8. That means it's an exceedingly photographically fast thing. What does that mean? It means we can take a picture of a dim nebula and capture it beautifully in 20 seconds and not 20 minutes. So we're running much faster. Yeah.
I remember those days we'd wait for a little bit longer for an exposure.
Yeah, remember? Yeah.
Ooh.
That's a really moody shot of a coming thunderstorm.
Oh, beautiful.
Yeah. It's one of the saguaro cactus out there that's on the property. It's right near the observatory. And this is what you see out there. It's a beautiful, beautiful sky, and there's no light pollution to worry about. Okay. We have these beautiful rays. Wasn't this, I took this picture, didn't I? Or did you?
I don't remember.
Okay. I know you sent me one that you had taken.
Yeah, it could be one.
These are called
I've taken so many. Yes, I just. Yes.
Now, what's hard for people to understand is these are called crepuscular rays. And the people that believe that it's a flat earth say, well, look at the angle they're going on. These are going that way, these are going that way, and these are going that way. If you try to tell them the truth, that they're all going in the same direction, they're all parallel to each other, they have a great deal of trouble understanding that. But they don't understand how big the earth is, and they don't understand how far away the sun is. And this is the same thing you get with railroad tracks. When you look at railroad tracks, they look like they're connecting way in the distance, and they get wider as they get closer to you. Okay. It's the railroad track illusion. If you saw this from 100, if you saw it from 50 miles to that side, you'd see the same thing. It's just an illusion created by the vast distance between you and the sun. But boy, is it beautiful.
It's gorgeous. So pretty.
Yeah.
We have great sunsets.
We do. They do. You do. I don't yet, but I do. Sometimes have them here.
Yeah.
Yeah. So we capture everything. And to give you an example, like on the 6th, just the other day, I captured a bunch of things. Okay. Like here, I captured this galaxy. All right. And you go into the processed thing, and now you see the photos. And so here's this galaxy that I captured. Okay.
Pretty.
And that's just like, that's a 25-second shot. And what I do is I take a 25-second shot, then a second, and stack it on top of the first, align it and stack, and just do that over and over and over, making an image sandwich. Oh, okay.
But don't eat it.
I know, don't eat it. Yeah. When you make that image sandwich, what ends up happening is you get this beautiful noiseless image. It's got much less noise in it. And so that's pretty cool. And so, further, like if I come back out and I go into, was I just here? I remember. Yes, I was.
You can go down rabbit holes. There's so many pictures.
I know. I'm not going to go too far down the rabbit holes. We have other things to talk about, but
it's all interesting.
Yeah. All right. So here's another one. This one here is really beautiful, and it's interesting because you see the turbulence of this galaxy. It has this dark stuff, this dark dust in it. Okay, that's not a void in space. That's actually dark dust inside this galaxy. This one's called a barred spiral. We have spiral arms, which look like beautiful spirals, but we also have these where the nucleus, which you see here, is extended to one side and the other, like a bar going left and right.
Okay.
And then you have an arm coming off here, going around there. You have an arm coming off here, okay, going around here. Okay, so you actually, and then you got another tighter one in here. So you actually have these arms that originate off the barred end of the nucleus. So it's pretty cool. And this guy, again, was another beautiful night's worth. And then, okay, this one here, this was called Thor's helmet. Again, this was taken with our wide field system. Okay, this beautiful object, that star right there has a special name. It's called a Wolf-Rayet star. Now, Wolf and Rayet were two astronomers, and they discovered that some stars have these massive stellar winds. Their effects are so powerful with their outflow of radiation in every direction that they literally push the outer layers of the star around the core outward. And that's what we're seeing here.
Beautiful.
It makes this beautiful nebula. And what happens is they then ionize that material that the star was made with. Okay. And in this case, it was a lot of oxygen and a lot of hydrogen. And so the hydrogen glows red and the oxygen glows teal. Really, really pretty. And that's what this one is. Now, we also did another photo of Thor's helmet with the Benson telescope, which is a much more magnified view. And this is what that looks like when you start.
My goodness.
When you close in on it.
Wow.
So you actually see now the star is here again, and now you can see more detail.
Oh, it's gorgeous.
Yeah, it's only 24 frames, and usually that's 24 stacked. We stack 50 to 80 to make it look better. But I was noticing that the winds out in Benson were cropping up, making it hard to catch this. So neat stuff. Now, all that said, so this then is the world of Skytour Livestream. You have the online database at your disposal. You can download any of those pictures you want. It doesn't cost you a dime. All right.
Nice.
Right. We give away equipment from time to time. We have winners of telescopes and binoculars. And if you want to get photographic prints, well, then you can get photographic prints. These are all images we took. And I like this one. This is a really cool one.
That's so pretty.
Yeah. Yeah. That was the day I put the flag in the sand out there.
Oh, that's a good day. Beautiful day.
It was. And so these are all objects that we took with the telescope out at the Sonoran location, the wide field scope. Yep.
Oh,
lots
gorgeous.
of very cool, very interesting imagery. So we're actually seeing the fabric of the universe before our eyes and creating it right here. Right in Skytour. Yeah.
And people can just download those and do whatever they want with those photographs.
Well, they can do more than that. Like, let's say they pick this one. They can actually get this on professional paper. They can get it on framed under glass. They can get a fine art canvas. They can have it put on metal. They can actually have it put on canvas as well. Cool. And so there's a lot of ways that they can actually get this. Now, I know Marianne in her living space, her living room there, she actually has some of these images
on canvas.
Canvas, all hanging up. Yep. Really,
They're
really
absolutely beautiful, and the prints are just really crisp and clear. Yeah. It's gorgeous.
There's an example. There's a fine art canvas example. And that's 16 by 24, but you can get 20 by 30 as well.
Bigger the better, because it's so pretty.
I know. They're really pretty. Yeah. Yeah. So these are all available to you up there. And we keep updating our database so people can get these up there. We're going to be at Contact in the Desert May 29th to June 2nd. I'm actually doing like 7 different talks. And I'll be doing 2 Skywatches with good friend Ben Hansen. Whenever we're together at a conference, they say, Mark and Ben. and they want us to do it. Ben does a Skywatch.
Ben and Mark.
Yeah, well, it's Ben and Mark in this case because this is his Skywatch.
Oh,
I'm just
okay.
along as the astronomer.
Oh, that's all.
Yeah, I don't steal anything from him. He's a good guy.
You both are good guys.
I like Ben. He's a really good friend.
Uh-huh.
Yeah, and so I'll tell you a little story. When we were filming Alien Invasion Hudson Valley, they had us staying in Danbury because of COVID. We couldn't cross the New York state line and stay in New York. Go figure. Okay. But there's tons of people in New York hotels, but we couldn't do it from Connecticut. Okay. Well, anyway, we're in a hotel in Danbury, and it's November. Now, it's cold. It was during the day when we were filming, it was probably 20 degrees, okay, in the teens at night. But we had a very strange thing happen. We had this warm front come ripping through, and this warm front brought with it a thunderstorm. It was not just a thunderstorm, it was a very bad thunderstorm. And it brought a tornado to Danbury, Connecticut. So I'm in the hotel room just like this, watching the TV or whatever, getting ready for tomorrow's filming, the next day. All of a sudden I hear boom, 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 banging on my door. What? I open the door, it's Ben. And all of a sudden he puts in my face this weather thing like on his phone. He goes, "Look, it's a tornado. Come on." I go, ooh. And we went to chase the tornado. So we run out to the black Suburban that we were driving around in because they give us this Suburban to film in and all that stuff. And so we go out to the car. The rain is coming down. You're soaked when you walk out of the building. And now we're getting in the car. As I open the door to the car, the rain is horizontally coming into the car. I get into the car. I sit down on the seat, and it's a puddle already.
I was going to say, it must be. Are you sure?
It was squench. Oh, gross. All over me. It just totally soaked me. And so Ben's like, come on, we got to go. And now we're racing along, and I'm sliding on the seat because I'm just all wet and slippy slidey. And so we're chasing it. I'm holding the weather thing. We're trying to see the tornado. We can see kind of the funnel, and we're trying to chase where it is. We're looking at the weather thing. I'm looking at the critical weather, bad weather map there, the dynamically updated one. And it's like, come on, we got to turn left. Got to left over here. Okay, here it is. Keep going. And we couldn't actually find it in the end. We couldn't get close enough. It's like the dog chasing the car. What the heck we can do if we caught it?
Smell the tailpipe. I don't know.
Yeah. It's like, okay, I got it. So as it turns out, we kind of lost it, and we were kind of upset. Oh man! So we're driving back. We're cold, and we're all wet. And we look out, and we both see Cold Stone Creamery, and we look at each other, and we go, ice cream. We pull it. It's freaking winter. Okay, we're cold. We just had this freak weather come through. We walk in, drowned rats, both of us. I'm walking across the floor because it's always that tile. Oh, very much so. And the thing was that tile, the vinyl tiles. So it was very obvious, like
friction. Yeah.
Right. Okay, and we're in here like because Ben and I walking in. And we're the only people in there except the girl behind the counter. And she's like this, looking at us like, can I help you? And we laugh and we go, well, we were just chasing the tornado and we couldn't find it. And she goes, oh my gosh, I heard about that on the radio. We're getting alerts to like be careful and go hide and all. Yeah, it's gone.
Oh, I would have got ice cream.
We did.
Every opportunity for ice cream, you should take it.
We got ice cream, and we go back out to the car. I'm sitting in there, it's all wet, and we're eating this ice cream.
Yeah,
it was really good ice cream in the middle of November, and it was really kind of fun. It was nice. So that made the night sort of worth it. I got back, took a shower again, okay, and warmed up a little bit because obviously being cold for that amount of time, leeching off a lot of my warmth.
Your heat, yeah.
Yeah. And then the next morning we had to get up and do it. It's like, it was very cold out there, but it was fun. It was a good time, So
Sounds like
anyway, yeah. So it was a fun time. It was a good time. So, and what did that have to do with getting photographic prints? I can't tell you. It was just a side story. What can I say?
That's all
But
good.
you can go to our site, check us out. You can connect with us on YouTube. You can connect with us on Facebook, X, Instagram, LinkedIn, or just email. And if you want to find us, there we are. And again, it's skytourlive.org if you want to find us. We'd love to. Oh, that ain't it. Okay. I think I must have hit the back key or something.
Oh,
there we go. Yeah. So that's where we are. You can find us again at skytourlive.org and enjoy. I hope you can, if you again want to support us, we'd love to have the support. We need the support. A couple pieces of equipment we're looking to do now is the camera we're using is old and venerable. It's the original camera we had on the telescope, but I noticed that the power to it's sort of intermittent, so we have to get it serviced. But we're looking to get a new camera, the 2600, which is a ZWO camera. And so we're going to work up toward that one. It's a camera that's going to cost about $1,499. But then again, this one cost that much when we bought it, the one we have.
Right.
Yeah.
And it'll go in the same spot where that other one is? Same thing?
It's going to go in our Benson telescope, right?
Okay.
Yeah, which actually,
nice.
As I think about it, I think maybe I could show you that.
Okay.
Because why not? Because why not? Okay, so let me just show a little bit of that. So okay. I will stop sharing right now on this. Okay. And I'm going to bring up something else.
Okay.
Is that okay? I think we got a few minutes left.
Mm-hmm.
Yeah.
Been great on time.
Yeah. So let me stop the screen sharing there and bring up the screen here. Share this beautiful window right here. Ta-da! There we go. All right. So there
it is. Ta-da!
This is the view of our Benson telescope. Now, it doesn't look like much. Okay. Now, I'm in Connecticut, and I'm 2,600 miles away from here, and I just have to do one quick check to make sure that we don't have any issues out there. And there actually isn't a cloud in Arizona right now.
It's pretty clear. It's very hot out.
Not a single cloud. So what I'll do, time out there is 6:42. So the sun's not quite down yet, but I will show you. From Connecticut, I'm now going to open the roof. Okay, here it goes.
Cool.
And I'm going to open this up a little.
Oops, we lost it.
Yeah, what happened? It's still here. Hold on.
That was teasing. We started to see it go.
It was a tease.
Yep. Makes you want to stay and watch for more.
Yeah, it's fine. It's here.
Yep.
All right. Let me bring it up again. I don't know. I think I actually hit the button by accident to off my mistake.
That's okay.
That's okay. We're good.
Okay. You're no bother.
I can't sing. Yeah. So here is the telescope right now, and what I'll do. Oh, I see what it did. Yeah. Okay. Right. Okay. Let me just do this one more time. Don't mind me. I'll be right back. Coming right back after this commercial break. All right. Yeah, I realize what happened. There's a little bug I have yet to work out, but we'll get it. I think this is the right one here, isn't it? Oh, wait,
Shirley it is.
Hey, quit calling me Shirley.
Mark it is.
Okay, here we go.
Okay.
So let me bring our screen up again right here. And now we're good. Okay.
Okay.
So this is our telescope out in the building right here, and not as easy to see right now, but that'll change in just a moment. So what I'll do now is I open the building, and I'm going to turn on the power to the building. Power's on. Okay. and the handset is now operational. Telescope is now operational. And now what I can do is connect to the telescope. All right, there we go. So this is our controls. I will tell the telescope to unpark and now go to the home position. This is, you'll watch it move. Now this,
Okay.
I'm making this happen from 2,600 miles away. And now the telescope
Oh, there it
moving up.
is.
There it is. It's raising up. Let's see if I can make that a little
Nice.
bigger for you so you can actually see it. There you
Neat.
go. Yeah. Yep.
That's incredible. What amazing what technology can do.
Yeah, and
That's
in this telescope, you see right here, the camera is at the back end. See it?
Mm-hmm.
It's the red thing on the back end. They've got all this gear between here and the back of the telescope. Okay.
Which is how most telescopes are, right? Like you said.
Yeah, exactly.
Mm-hmm.
Mostly the back end. And what we're going to do is we're going to take this camera, which is the old one, and we have to replace it with the new one.
Okay.
The new one, in fact, let me do this. Okay, because I think this will actually be a little easier to see.
Yeah.
Maybe even this. Maybe that's a
little
too much. We'll find out. We're getting there. There we go. Yeah, here we go. Okay. All right, so now here's the camera at the back. This round thing is a filter wheel. So we have all these different filters in here. All right. Then we have a guider here. There's another camera right there. We have an automatic focusing system right here.
Wow.
And then we have this lens here, which actually reduces the amount of time we need to take exposures. It makes us go from an f10 down to an f7 telescope. Okay. But this camera is the old one. That's the one that we're having some issues with that we have to replace. This mount, we have another one of these mounts, and the telescope that's out in Wickenburg, in that telescope out there, all right, that telescope is eventually going to be put on one of these exact mounts and use the same exact approach that we use here.
Cool.
And that's going to be very, very, it's going to be much better for us. So this is an 11-inch diameter telescope. It's actually a really good size for what we're doing. You can see that it has this long barrel to it, which is gorgeous.
It's like a cannon.
It's a stellar cannon. That's exactly right.
Okay.
Yeah. And so this allows us to get some shots that are really beautiful. And so that said, I'm really happy that with the funding that we got from folks that donated.
Absolutely. Thank you.
Yeah, especially ERRT Radio donated to help us get this telescope in the first place. That's Ronald.
Thanks, Ron.
Oh, yes. Amazing guy. Saw a bird fly over. Okay. And so that said, there it is. And so now it's actually in its ready to go position. It's actually kind of aiming at the North Star. But what I'll do now is I will send it back to the park position.
And it's too light to really expose anything. Is that correct? You have to wait till it's dark.
Yeah, right now it's a little bit too light. I mean, I could see some of the brighter things out there, but right now it's still just a little bit too bright. Okay. Again, we are an astronomical telescope, not a daytime telescope. Although I did have the telescope looking at the distant mountain because I mounted it really high so you can actually look over the top. And I actually looked at the highway, the 10.
Oh.
And I saw trailer trucks going by and everything. It was really cool.
Wow, that's awesome.
Yeah, but the focus is so much closer, that it takes a long time to get the focus back out electronically. So it was for testing. Yeah,
that's interesting, huh?
Yeah. All right, so now we're gonna go back to park. You'll watch the telescope. It's gonna move itself back to the park position. This is a indicator of the telescope's motion. You can actually watch it.
That's cool.
Yeah. And so when it finishes its motion, its movement, I will then be able to turn it off, and it'll say it's at park position. Okay, you'll see the word park show up there. There we go, parked. And now I can come over here and disconnect and shut this down safely. Okay. And so now what I would do is I wrote this program to do observatory control stuff, because it's just you can get a canned thing, but they're so expensive. I just wrote one myself, So now I'll
Very
turn the
good.
power off. Okay, now power's off, and I will now close the building.
Cool.
I
There
know.
it goes.
There it goes. It's really cool.
Nice and smooth. Now you can see the telescope. Wow.
Yeah, when the glare is out.
Yeah.
And it has an infrared setting, but there might be a little too much light. So right here, it should convert over to infrared, but we actually have a little too much brightness coming through that crack in the ceiling. So it's just enough to fool the camera, because the camera's up high with the telescope. Anyway, so there you go. And that is our Benson scope that everybody helped with.
Great
And
tour.
I wanted to thank folks for all that they've done, and so that said, we have tons of other things we're going to do. Right now, the moon is waxing gibbous. It's almost going to full. And we tend to, good question, Karen. We tend to wait till after the full moon to take images, because the moon looks great, but the full moon is no contrast. You see nothing, because the light hitting the moon is going straight to it and then coming straight back to you. So, we don't actually have we don't have a way of getting any contrast except at the extreme edge, and that's really not a whole lot to see when you got mostly flat, washed out features.
Do they have filters to block the moon out?
Actually, yeah, that we use 2 filters that block out most of the moonlight. We've taken pictures at the full moon of faint nebulae, but they are affected by the moon. The color is off because of the moon, and so I tend to avoid it. And then I want to. Oh, thank you. You're welcome. That's Kathy Pernasek. Hi, Kathy. Thank you. And then Karen said, "What do you do for power?" Well, the telescope out in the Sonoran Desert is powered by solar. It's a solar-powered telescope, solar panels, courtesy of the landowner. So everything is that, and of course, this one here, she's very familiar with that telescope. Actually, you're going to be doing a maintenance run, you said, on the telescope.
Yeah, hopefully next week, maybe, or week after. Yep.
Sure.
Gonna try to get that in.
Yeah, no, thank you. That's fantastic.
Look forward to it.
Yeah. And let's see. I gotta see if I've got this on here. I think I have this. I know I do. I mean, hold on. Let me find it. There it is. Okay. You know how it is. It's Arizona. We've got creatures.
We do.
Okay. And we have creatures, and a trigger warning. One's about to show up on your screen. Okay. We have creatures like that. What a little cutie this guy was.
God.
Now, I wasn't there for this, unfortunately. I would have begged to hold him. These little guys are harmless. They look big. That's a spider, yes. Okay.
Right now, it is.
Right now, Bill Skywatcher, our producer, is probably going, because he hates spiders, don't you, Bill?
Oh, he's saying, "Oh God."
yeah. He's looking at me. Oh, I can't believe he's showing it, or he's sleeping.
No, that woke him up.
Yeah, right. So yeah, this was found under the computer, wasn't
it? It was. We were sitting there, and it's called an
An
That's what Marianne pointed it out to me, and that's all she could say
before she ran away. And the thing was,
it's scary when you're not expecting it.
I was on the phone at the time with Marianne and Tara and Tara's husband Dale, and and Dale's seasoned. He understands they're harmless, like I do. But I mean, I'm not stupid. I'm not going to say, "Hey, let me just grab that thing," But as long as you're gentle, they don't care. Yeah. They're not interested in biting you. And if they did, they have fangs that are 3/4 of an inch long. But you know what?
My.
They don't have venom that's going to hurt you. It's just a like, damn, I got bit by a lizard or something. I mean, it stings, it hurts, yes, but it's not poisonous. Now, go to South America, on the other hand. Well, that's different. The tarantulas down there can hurt you. What you worry about out here, though, is the scorpions,
Yeah.
The big scorpions actually aren't that bad as those little guys, the bark scorpions, which are those little monsters.
And they're around.
Yeah, I hate those things,
And they play dead, yes.
Interesting, too, the scorpions, when you hit them with an ultraviolet light, their carapace, their shell, they're arachnids, they're in the spider family. They glow a bright blue. So they have that beautiful luminescence, and you can see them from a long way away. So when you shine the light into the cactus, you see where the scorpions are. So they give themselves away, but they don't know it. Hey, Frank, how come he can see us? I don't know, Mel. I'm just sitting here doing nothing.
Oh my gosh.
Yeah, but on the when we go out to Weaver's Needle Vista, it's called, when we do training out there for MUFON, Mutual UFO Network.
Yep.
You go in the parking lot when it's dark and you shine your light down and you see these blue splotches, hundreds of them all over the parking lot. And that's the scorpions that got squished by cars coming through.
Oh, that's just
you see, there's a lot. And if you walk down the sidewalk, you can shine in and see the scorpions. And
that's always fun to do.
Yeah, but for people that've never seen a scorpion before, a scorpion is just a creature they see on National Geographic. When they see it in real life, it's like, ooh. But they have to understand that ooh could turn into if it bites you.
It's an not
that's like my first experience with the cholla cactus.
Yeah, that was
I won't be talking about that tonight, though, because we're out of time, unfortunately.
Okay. That was fun, Mark. Thanks so much. What a great tour.
Thank you so much. That was very good. Hope you guys enjoyed it. I hope you liked the talk and the sharing between us and the final bits about the observatory. Other than that, we hope you have a fantastic tomorrow, and we'll see you next Wednesday on Sky Tour Live. Good night, everybody.
Bye, everyone.